snow and ice equipment. And the majority of this research took place at the University of Akron, with some of our testing happening at a facility in Berea. I would like to start out by acknowledging the ODOT Research Technical Committee, who helped us a lot during the completion of this project, as well as the ODOT Research Office, and Jamie Hendershot from District 10 for also giving us some input. Most of our testing, the accelerated corrosion testing we'll talk about, took place at light curable coatings in Berea, and that was held under the guidance of Dr. Ben Curatulo. And most of the research that I'm presenting today was not actually completed by Dr. Miller or myself, but by a team of graduate and undergraduate students at the University of Akron, specifically Alvaro Rodriguez, who is one of my PhD students. So I just wanted to start out by kind of giving an overview of why we undertook this project. Corrosion is a huge issue in the United States. We lose over $220 billion on corrosion annually, 15% of which is avoidable. The main problem with winter maintenance equipment is that de-icers that we use to prevent the roads from forming ice corrode winter maintenance vehicles, and they cost about $1,500 per ton in damages. There have been some studies that have shown that soap and water may not be enough to really clean the vehicle and remove some of the salt residue that's present. However, there's some potential solutions, the most common of which is coatings, which we'll talk about a little bit. The second one is salt neutralizers, the use of salt neutralizers. We undertook this project because we wanted to look at the effect of both coatings and salt neutralizers on reducing corrosion. However, there's not really a lot of literature out there, or a lot of studies that have been conducted on how salt neutralizers affect the corrosion, if they protect equipment, what kind of effect they have on the metal surface, and if they're actually doing the job that they say they are in preventing corrosion. Just to give you a quick overview, I'm going to be talking a lot today about what's in a salt neutralizer, so I wanted to give you a quick kind of discussion about what's in a salt neutralizer. They contain two main components. One is the cleaning agent. It's typically an acid, not always. Two of the salt neutralizers we tested contain a proprietary compound that's non-acidic. So sometimes hydrochloric acid or sulfamic acid, which is a less strong version of sulfuric acid. However, this acid can be corrosive to the metal surface. So you're using it to wash the metal, however, it itself can be very corrosive. So they also add a corrosion inhibitor. That is typically a surfactant. If you look at the top left-hand corner of the right-hand corner of the screen, you'll see a surfactant molecule. A surfactant molecule is really two parts. It's got a head that loves water and an oil-loving tail. So it will form a layer at the surface of the metal and essentially protect it while it's being cleaned. So it will protect it from the acid. So you can see that the surfactant concentration is very important. I'll be discussing the concentration of the surfactant a lot further into the presentation. At low concentrations of surfactant, you can see this plot is versus 1 over the corrosion current, or essentially how much it's corroding. So you can see at low surfactant concentrations, there's not really a lot of adsorption on the surface. There's not a lot of protection during cleaning. As you increase the surfactant concentration, you get more of a layer, and then above a certain point, the layer is there, and you see some protection. This helps not only during the cleaning process, where you are protecting the surface from corrosion by the metal, but also if the binding onto the metal surface is strong enough, it will protect the metal after the wash is done and during the use of the metal. Also, corrosion protective coatings have been used. They have been shown to be very successful at preventing corrosion. You can see in this figure in part A, you can see a scribed metal sample that was coated with one of the light curable coatings from the facility in Berea. You can see after 3,000 hours in a salt spray chamber, the scribe is where the bare metal is. So that would be where corrosion is happening. To monitor how effective the coating is, you make the scribe, you put it in a salt spray chamber, and then you monitor the corrosion or the rust from that scribe. And you can see after 3,000 hours in a salt spray chamber, there was no effect from the corrosion, so the coating is protecting the surface. You can see in B, the lower figure, you can see the step into a cab, the cab of I think that's a bulldozer. You can see before they put on the corrosion protective coating, you can see some rust on the surface. If you look at the next picture over, you can see that that has been protected with a corrosion protective coating, and there is less corrosion happening on the surface. So now that we've given you kind of a background about what we're looking at and why, we had 4 main objectives that focused on corrosion prevention alternatives. The first objective was we wanted to perform a thorough literature search on the effectiveness of salt neutralizers on bare and coated metal surfaces, as reported by ODOT, mainly in this survey. The second objective was to look at the commercially available salt neutralizer products in removing salt residue and preventing corrosion on bare metals, electrical connections, coated metal surfaces. We focused mainly on the laboratory scale for this objective. For objective 3, we wanted to look at a cost-benefit analysis of the top performing salt neutralizers to kind of see what's really giving us the best bang for our buck. And then objective 4, we looked at some deployment strategies or some recommendations for implementing what we found in our study. The tasks that we used were to do a survey. So we did our effectiveness of salt neutralizers by sending a survey out to the ODOT districts. Our second task was to do some data collection. That was mostly laboratory and accelerated corrosion experiments, and I'll explain those in further slides. And then we did our cost analysis using the commercially available salt neutralizers. And so this is just a quick overview of our anticipated results. Basically, our main anticipated result was anticipated result 2, where we wanted to have kind of a ranking of commercially available salt neutralizers based on corrosion rates, and also the cost analysis. And then this led directly into our recommended washing strategy that we wanted to be consistent with ODOT maintenance and administration manual. So just to kind of give an overview of what we found the online survey showed that about 62% have used salt neutralizers in the past. One of the questions that we asked them was to rate their feeling on the effectiveness. So based on their kind of anecdotal experience using these salt neutralizers, one response said that it was very effective. 10 responses said that it was effective. So we have the majority of the people who responded said that they felt that it was an effective effectively used to prevent corrosion. 3 people thought they were slightly effective, and 6 were not sure because they were using salt neutralizers for the winter season 2012 to 2013 before as we were taking the survey. We also found that the majority of people who were using salt neutralizers or had used them in the past discontinued use of the neutralizer based on cost. So 80% said that they stopped using the neutralizer because it was too expensive, and they didn't feel like they were getting the benefit that they needed based on the cost. 1 respondent said that they were ineffective, and 2 respondents said that they discontinued the use because of time constraints. So one was, the main thing was the cost, so they didn't see the benefit that they wanted. 1 did not see effectiveness, and then some time constraints associated with the washing. We also asked about corrosion protective coatings. We found that about 36% of the respondents use coatings to prevent corrosion. And again, we saw that 2 people thought they were very effective, 9 respondents said that they were slightly effective, and then 6 said that they were only slightly effective, where 3 were not sure based on the fact that they had just only implemented this while we were asking for respondents for the survey. And then of the respondents that we had, 48% of them use coatings and salt neutralizers in combination. So one of the things we wanted to see is some facilities use coatings, some facilities use salt neutralizers. Was there an effect of using them in combination? And so we wanted to make sure that we tested the coatings with the salt neutralizers in combination so that we were getting a more accurate description of what was going on in ODOT facilities. So we use these online surveys to select the salt neutralizers and the coatings that we then tested in the laboratory. The neutralizers listed on this slide are the ones that we tested. We tested BioClean. It has a proprietary cleaner, so we don't know what it is. It is basic, though, when we test the pH, so we are assuming it's not an acid. And its recommended wash concentration is 3%, so it's pretty low. We also tested Consalt. Its strong acid cleaner is hydrochloric acid, and its recommended wash concentration is 10%. We also tested Eastwood and NutriWash, which are both sulfamic acid-based cleaners, and they have a recommended wash of 5 to 11. Saltaway is also a proprietary cleaner, so we don't know what that is. It also tested basic, so we're assuming it's not an acid. And its recommended wash concentration was 10%, and Winter Rinse was the last that we tested. It is a sulfamic acid-based cleaner, and its recommended wash concentration is 4%. So you can see that these range anywhere from 3 to 11% in the recommended wash concentration. What we did was we took our samples. You can see in the top left-hand corner the salt chamber. That salt chamber runs at 95 degrees Fahrenheit. It has a certain weight percent of sodium chloride solution, so 4 weight percent sodium chloride solution. The coupons are loaded in the bottom left corner. You can see them on trays. They're loaded and labeled, so you know which coupons are which. They were removed, so we had, they would run for 336 hours in the salt spray chamber. We would remove a test set of coupons, and we would wash them with the salt neutralizer based on the manufacturer's instructions. You can see in the top right-hand corner the little wash setup that we had. We used a simple hand washer to wash them. Some of them were first washed. They were always washed with soap and water first, or based on whatever the manufacturer recommended, then washed with the salt neutralizer and then rinsed with water. And then they were put back in the salt chamber for further testing. Our reference set of coupons were rinsed with just water alone and then soap and water as a reference for how much corrosion was prevented with respect to soap and water, which is what's commonly used. The first results that we had were very puzzling to us. They indicated that the effectiveness of the neutralizers is alloy specific. So you can see here in this bar graph, the y-axis is the reduction in corrosion rate. So it's a percentage, and this is compared to soap and water. So we used soap and water as our baseline and said, okay, if everyone's washing their truck with soap and water, we'll call that the baseline. How much more corrosion prevention do you get from using a salt neutralizer? There's a couple things that I want you to kind of take away from this graph. The salt neutralizers and the alloys vary, the effectiveness varies significantly. If you look at the blue bars, that is the aluminum 2024 T3 alloy. You can see that 5 of the 6 salt neutralizers provided some corrosion protection for aluminum. So you can see BioClean, Eastwood, NutriWash, Saltaway, and Winter Rinse all showed a significant reduction in corrosion with the application of any of those salt neutralizers. It's also interesting to note that Saltaway was the only salt neutralizer that we tested that prevented corrosion with respect to soap and water on all of the alloys that we tested, whereas Consalt actually increased corrosion on all of the alloys that we tested. So we looked at this and we thought, okay, so this is alloy specific, it's also neutralizer specific, and we wanted to make sure, one, these tests are a lot of money, so we wanted to make sure that our results were accurate, so we wanted to dig a little bit deeper, and two, we wanted to see, so we did our survey and some people really liked these salt neutralizers, so we wanted to see what might be happening in our setup, what should we do for recommendations for wash procedures. Here's just some results that show what the corrosion looks like. The top images are scanning electron microscope images, or SEM images. The first one on the left is the bare metal sample for carbon steel before it went into the the salt spray booth. The STM image in the middle is without any application of salt neutralizer, so with soap and water. And you can see that the surface is corroded slightly. And then if you go one over, you'll see the same image that has the same metal but only washed with salt away. And you can see on the surface there's some corrosion, but you can also see some what looks like organic molecules there, which is probably the surfactant layer on the surface of the metal. On the bottom, that is aluminum washed with the 6 different salt neutralizers. And you can just see the surface of the metal, what it looked like after it came out of the salt spray chamber. You can see there's some corrosion on the surface, so the corrosion was visible after we removed it from the salt spray chamber. So one of the tests that we wanted to run was to see how well the salt neutralizer was binding to the surface. Since we saw that the success of the salt neutralizers was really metal or alloy specific, we wanted to see, okay, how strong is that binding happening to the surface? So we went back to our lab at the University of Akron, and we ran some polarization tests. Basically what we did is we put the metal sample in a salt solution and varied the potential and measured the current. And that will tell you how likely something is to corrode. And from that, we did that with and without salt neutralizer present in solution. And from that, you can determine how strong the binding is and how well the salt neutralizer is theoretically preventing corrosion. So what we wanted to do was determine the surface coverage. So I showed at the beginning of the presentation the figure that said at low surfactant concentrations, there was not very much surface coverage, and then at higher concentrations, the surface was covered and then protected. So what we can do is theta, the equation for theta, is equal to 1 minus the current of the inhibited, or the current with the salt neutralizer present, divided by the current on the bare metal. And we can use that, we can take the concentration of surfactant divided by that surface coverage and plot it versus concentration, and we can get an absorption coefficient. Now that really doesn't mean very much, except that the higher that number is, the more effective the surfactant is binding to the surface. So we wanted to see which surfactants and which salt neutralizers had higher K effective values. So anything higher than 1 is considered good, and then the larger values are above 1 or even better. So what we found is that the neutralizers with the larger K effective values in general showed reduced corrosion in the salt spray testing. If you remember, I mentioned that aluminum had 5 of the 6 salt neutralizers reduced corrosion on aluminum, and you can see in the second, or I guess the third column over, that the effective absorption constants for aluminum are mostly greater than 1, with the exception of consalt, which we had some trouble accurately obtaining. And so that made sense to us. Then we looked at A36 and copper, and we saw that those also have very high K effective absorption constants. And we thought, well, those didn't have very good performance with salt neutralizers in the salt spray testing. So we decided that not only is the salt neutralizer alloy specific, it's also concentration specific. So maybe the concentrations that we were using or that were manufacturer recommended were a little too low. So we wanted to make sure, based on this information, that we tested what the effect of the concentration of the salt neutralizer was as well. And so what we also looked at then, since we had this data, was what the surface coverage was. And you can see that salt neutralizers that had a manufacturer's recommendation for a concentration above the critical wash concentration, which I'll talk about in a second, were more effective at preventing corrosion. So those with a high surface coverage, you can see for NeutraWash and Salt-Away, as you increase the concentration of the salt neutralizer, you also increase the surface coverage. So you're increasing the corrosion protection at the surface. And so what we looked at was, so Salt-Away prevented corrosion on all of the metals that we tested, if you look at salt away, the critical wash concentration, again, I'll talk about what that means in a second, and the manufacturer's recommended wash concentration, they were about 2.5 times higher. So we wanted to use that as a baseline to see, okay, if we use all of the salt neutralizers at 2.5 times their critical wash concentration, will they be effective at preventing corrosion? And you can see that we ran, that what we did was we took only A36 to run these again because these tests were kind of expensive, and A36 showed the most corrosion of any of the metals that we tested. So we tested A36 at the recommended wash concentration, and then at 2.5 times the critical concentration. So at 2.5 times the concentration where you start to see surfactant kind of blocking the metal sites. And you can see that now all of the salt neutralizers tested prevent corrosion or reduce corrosion in comparison to soap and water. So you can see that salt away still reduces corrosion, whereas all of the other surfactants or salt neutralizers that didn't prevent corrosion in the past are now reducing corrosion on A36 compared to soap and water. That 10%, the red line that's there, that is just sulfamic acid, so we wanted to make sure it wasn't just an increase in acid concentration that was causing it, it was actually a surfactant issue. And so you can see that most of them are still above that 10% that the sulfamic acid reduced corrosion. So basically the takeaway message from this, next slide, is that on all of the bare metal surfaces that we tested at the manufacturer's recommended wash concentration, salt away was the only one that reduced or had a small impact on the corrosion rate compared to soap and water. Some of the commercial neutralizers actually increased the rate of corrosion, especially on carbon steel and copper, which are two metals of particular interest when we're talking about winter maintenance equipment. And the reason for that is because they're alloy specific, so certain salt neutralizers are better for certain metals, and it's also concentration specific. So if you're not using your salt neutralizer at a high enough dilution rate or wash concentration, you're not going to get the effectiveness that the manufacturer is claiming to get. However, we want to note that this may significantly reduce the cost effectiveness of the neutralizer application. So if you are increasing your concentration of neutralizer, you are in effect decreasing the cost effectiveness of the neutralizer application. So that was the main idea from the corrosion testing is one, that the salt neutralizer, the accelerated corrosion testing we did initially, those results all make sense based on our laboratory experiments. And it's very important to use the correct neutralizer alloy combination as well as the correct neutralizer concentration, or you're not going to get the effectiveness. And so that takes us back to our survey results where we showed that some people really liked the salt neutralizers that they were using, some did not, probably depending on application, where some thought they were effective and some thought that they weren't. We then wanted to look at how do these salt neutralizers affect the performance of coated metal samples. So we did corrosion testing or accelerated corrosion testing exactly the same way that we did this for the bare metal samples, and we tested them with the top 3 performing salt neutralizers. And we did accelerated corrosion testing for a little bit longer in this case. For the scribed samples, we did 7 days. So the scribed samples, again, are the coated metal samples with the X in them so that you can have the bare metal exposed and see how far corrosion occurs from that scribe. And then unscribed samples to see how the corrosion protective coating is holding up. We did those for 14 days. And the performance of the coating was evaluated in a couple ways. One was to do a visual inspection. So we just looked at it, saw how much it had corroded, just to see how the coating looked. And another was electrochemical impedance spectroscopy. Basically, this is a technique that just tells you what the how the coating looks, even though you can't see underneath the coating surface. And the 3 corrosion protective coatings that we tested were Lubriseal, the light curable coating, which was from the facility in Berea, as well as manufacturers' recommended paints. We did some adhesion testing. So we tested the adhesion of the coating to the metal. You can see how the coating held to the metals that we tested. We tested carbon steel. We tested 2 alloys of aluminum and then 2 alloys of stainless steel. And we also tested the hardness of the coating, and those ratings are seen in this table. So what we wanted to do for our scribe samples was to determine the creep rate. Creep rate is basically just a term that people use to describe the amount of rust from the scribe at the center of the coupon and how far out that goes. And you can use that to determine a coating rating. You can see the picture here is 3 A36 samples that were scribed, and you can see that there is a significant corrosion from the scribe. If there is 0 corrosion from the scribe, you would give that a coating rating of 10. So 10 is the best coating rating that you can get, and you can see that they go down from there. If you have 0 to 0.5 millimeters, your coating rating would be a 10, and then if it's over 16 millimeters, your coating rating would be a 0. So we found that most neutralizers don't reduce corrosion on the coated metal samples. So the neutralizers, we've talked a lot about how they interact with the metal surface. The coating does a much better job at protecting the surface from corrosion, and the neutralizer doesn't really add much to that. You can see that for aluminum and stainless steel, there was really no corrosion from the scribe at all. The creep rate was essentially 0. For the light curable, for the Lubriseal and the OEM paint, the coating rating was a 7. So if we look back at the previous slide, a coating rating of 7 meant that there was anywhere from 1 to 2 millimeters of rust from the scribe. So that coating rating was around a 7. However, on the light curable coating, there was a decrease in creep rate by 28 and 34% respectively. So you can see for Saltaway and Eastwood. So on the light curable coating, the Eastwood and the salt neutralizer actually reduced the corrosion rate and the creep rate significantly, and those had a coating rating of 8 instead of a coating rating of 7. So again, for the most part, the corrosion rate is not reduced on coated metal samples. However, for some of the coatings, there was some neutralizer-specific corrosion prevention. We also wanted to look at unscribed samples. So to do the effectiveness of a coating on an unscribed sample, instead of using the scribe where you measure the rust from the center of the scribe, you measure the percent of area that has failed on the metal, on the coating surface. So you can see the light curable coating is the top coating. These are also on A36. You can see that there's basically 0 coating failure. For OEM paint, there is some blistering. You can see a little bit of coating failure. And then for the Lubriseal, there's a lot of rust coming through even though the metal sample is coated. And you can see that there's really no effect, at least looking visually really quickly, of application of salt neutralizer. And so here we can see that the light curable coating had the highest coating rating, and that the Saltaway and Eastwood, again, reduced coating failure on the light curable coating. So much like the scribe sample with creep rate, you can see that on the unscribed sample, or the sample without the scribe in it, that the light curable coating had the highest coating rating, and that the Eastwood and Saltaway, again, increased the coating, or reduced the coating failure. It's also important to note that we like to do everything 2 different ways, so the fact that these results are corroborated was very promising to us in terms of the Saltaway and the Eastwood, preventing corrosion or reducing corrosion and coating failure on at least one of the coatings that we tested. However, we did some visual inspection, and that's a great way to see if your coating is functioning or not. However, one of the things that everyone wants to do is prevent the corrosion from happening before it happens. So visual inspection is great. You can see when there's corrosion, but we wanted to look and see how well the coatings were holding up underneath the surface, or what you can't see visually. One of the ways to do that is to run what's called an electrical impedance spectroscopy test. That's really just a fancy way of determining how much water is in the coating. You can see in the top picture, that's the cell that we used. You would put the coated metal sample into the cell. You would have your solution of sodium chloride with or without salt neutralizer, and then you would have 2 electrodes, and basically what you do is you change the potential and again monitor the current. And that will tell you what the pore resistance is. When you decrease your pore resistance, that means that you have water in your coating. So a smaller pore resistance or a lower pore resistance means that your coating has some water or some sodium chloride ions in it. What's important to note with that is that even though you coat a metal surface, water and salt can still get into the coating, and the faster that happens, the faster your coating breaks down. So the faster your coating needs to be replaced. So you want to make sure that the better coatings have the higher pore resistances and the longer time to degradation. How you can tell that is if you look at the plot on the lower right-hand corner, the good coatings look like a straight line. The intermediate coatings have kind of a level plateau and then a straight line, and then the poor coatings are basically just flat. So you can see visually, even without doing any kind of calculation, that the good coatings look like a nice straight line, whereas the intermediate coatings you can start to see breakdown and all the way to poor. So we looked at, just as an example of what some of that data looks like, for the light curable coating on carbon steel, we did an initial impedance on the coating. You can see that is the blue line. It's almost all the way at the top. You can see the blue kind of diamonds. So you can see that initially the coating was really good. What's important to note here is that Eastwood, Saltaway, and a water rinse show that they maintain the coating. So the coating looks good. So the visual inspection says that it looks good, the coating looks good, and the impedance looks good. But for soap and water and NutriWash, you can see that now we've moved down to a poor coating. So there's been a lot of coating failure. So by doing these analyses, we can see that even if we don't see a degradation with visual inspection, you can use this technique to see if the coating is breaking down. So you can use this to predict how long the coating is going to be effective. So sometimes this will correspond to visual inspection, and sometimes this won't. And if we look at some of the pore resistances that we calculated, if you remember, the higher pore resistance, the better. You can see for the light curable coating, all of the pore resistances are very high, which is good. Even Saltaway has a higher pore resistance than the initial coating. So using the Saltaway, using Eastwood water, you can see that that actually maintains the integrity of the coating longer. For things like the OEM paint, you can see it starts out with a great pore resistance, and then even though visual inspection did not show that the coating had really degraded to the point of failure, you can see that there is a lot of water uptake. The coating isn't as good as it was when it started out. And for the Lubriseal, the pore resistance started out very high and then degraded rapidly for any of the washes that we used. So we used this technique to say, okay, even though the visual inspection didn't show that the OEM paint was not preventing corrosion, we can see that it's still not maintaining coating quality like the light curable coating. And the Lubriseal, the coating rating was always pretty low. So our overview of the results from the coated metal testing, or kind of what the takeaway is from this, is the ability of coatings to prevent corrosion is also alloy and wash specific. All carbon steel samples that were scribed without neutralizer application exhibited corrosion. The neutralizer application did not affect the majority of the carbon steel scribed samples. However, the better coatings, like the light curable coating, the best coating that we tested, the average creep rates for salt away and Eastwood were better than soap and water. So if you have a really good coating on there, you're going to get the corrosion protection from your coating, and then using the salt neutralizer application will further enhance the corrosion protection. And we used some EIS testing just to corroborate these results, so just to make sure that what we were seeing in the visual inspection looked like what was actually happening underneath the coating surface. And we found that even though some of the coatings didn't appear to be corroded or blistered yet, they were closer to it than the visual inspection would say. So there was some corrosion breakdown and corrosion protection occurring at the metal surface. So we used non-visual, or the EIS testing, to just kind of validate what we saw and to see which corrosion protective coatings were on the brink of failure. From there, we wanted to look at a cost-benefit, or a cost analysis, on the 3 top performing neutralizers. We looked at 4 cost factors. We looked at what the neutralizer solution was, and we calculated that in dollars per gallon. All of the neutralizers had different recommended wash concentrations from the manufacturer and different wash concentrations that we found to be the most effective. We also looked at the dilution ratio. So this comes into play with the recommended wash concentrations. And then the neutralizer volume used per wash event in gallons, and that would be for the number of trucks at a given facility. So these were the equations that we used to determine the cost. The neutralizer cost per truck per wash event was the dollars per gallon times the dilution ratio times the number of gallons per wash. The neutralizer cost per facility per winter season was equal to the trucks, the
value above it.
The value above, I'm sorry, the cost per truck per wash event times the number of trucks at the facility times the total number of wash events in a given season. And then we annualized the capital costs using an interest equation so that we could figure out what the cost would be per year. So for the top 3 performing neutralizers, we had Salt Away, NutriWash, and Eastwood. Again, those were determined during bare metal testing. The concentrated solution cost per gallon, Salt Away is the least expensive at about $16 a gallon, and then Eastwood and NutriWash are pretty comparable at $37 and $30 a gallon. The dilution ratio, or the modified dilution ratio that we determined would be the most effective in volume percent, was between 10 and 14. So the Salt Away was, again, the smallest dilution ratio, so it's the least expensive, the smallest dilution ratio. NutriWash was 14%, Eastwood was 12%. So the usable cost for Salt Away was significantly less than for NutriWash and Eastwood. And then just as a reminder, the steel corrosion rate reduction compared to soap and water on the bare metal for Salt Away was 32%, so it was the highest, and then NutriWash and Eastwood were at about 15%. So just to show, Salt Away is the most cost-effective of the top performing salt neutralizers. You can see on the neutralizer cost per truck that Salt Away this is a function of wash volume and wash volume per wash event. So you can see as the gallons per wash event goes up, the cost of the salt neutralizer goes up. So you can see that the higher wash volume you use, the bigger difference you're going to see between the 3 different salt neutralizers. For salt away, the cost per truck as a function of wash events and wash volume per event. You can see if we have 5 wash events at 50 gallons of wash, it's about $405. So you can see that salt away is by far and away the most cost-effective of the top-performing salt neutralizers. Again, how much more cost-effective it is going to depend on your gallons per wash event, your number of trucks, and the wash events that you have. So what we found is that neutralizer application can increase the useful life of the truck by 6 months to a year. You can see that for a tandem truck that has a capital cost of $140,000 and a 7% discount rate, that if we have for 8 years, 10 years, and 12 years, you can see the cost of the truck will go down if you're extending the life of the truck from 6 months to a year. And so just as an overview of the cost-benefit analysis, the cost to thoroughly wash a single truck is significant and can vary by up to 300% depending on the neutralizer product. For the top-performing neutralizer, the cost for a full 350-gallon wash per truck would be about $560 for salt away, up to $1,800 for NeutraWash. If salt away is applied at a reduced volume and the neutralizer is applied for 5 wash events per winter season, the total cost per year to wash the truck is about $405 at 50 gallons per wash of the salt neutralizer and $810 for 100 gallons. And assuming the replacement cost of an ODOT tandem truck is about $140,000, the neutralizer solution can increase the useful life of the truck by 6 months to a year. Washing with salt away 5 to 18 times per year is cost effective. And this could be even greater because we're not taking into account the cost of the maintenance on the wiring or the maintenance of the truck. So this brings us to some of our recommendations for the general use of neutralizer products. The first one is for garages that are using any of the neutralizer solutions tested, we recommend that they are used above the minimum concentration that we determined. Our lab results support salt away as the most effective salt neutralizer wash for reducing corrosion on bare metal and coated surfaces. And based on this preliminary cost analysis, if we were going to pick a neutralizer to apply, we would recommend salt away. Field testing of corrosion behavior of metal samples utilizing the standardized washing procedures and equipment is needed to confirm the effectiveness of salt neutralizers that we found in the lab. And the review of data mining of maintenance records for prioritizing preventative maintenance actions and protecting metal surfaces would need to be done to really figure out what the cost benefit is. When we look at recommendations for the general use of coatings, we found that overall the light curable coating is the most effective coating for corrosion prevention. This was based on its performance on all of the metal surfaces tested. For garages that prefer Lubriseal, we recommend that the coating exceed 1 mil. We found that perhaps the coating, the Lubriseal coating was a little too thin, so we want to make sure that you use it above 1 mil. Statistically, our neutralizer application didn't really prevent corrosion on coated samples. However, the creep rate for salt away and Eastwood were better than soap and water on the light curable coating, which was the best coating that we tested. And again, field testing of corrosion behavior and durability of the coated metal surfaces is necessary to corroborate any of the things that we found in the lab. These are just recommendations based on what we found in the lab. Obviously, these recommendations would need to be field tested. And at this time, we can take any questions that you might have. Okay, so the question in the room was how we determined the critical wash concentration. We did that based on UV analysis. So what happens is, and I should have explained this a little bit better in the presentation, but if you look at this slide here, what happens when you increase the surfactant concentration is it goes from surfactant molecules in solution to kind of aggregated molecules, so either on the surface of the metal or just aggregated in solution. So what happens is the UV absorbance will go up. So what we did was we increased the surfactant concentration in a solution. We did this with and without the sodium chloride present. And then what happens is you can see, much like in this graph where there's maybe 3 different slopes, you can see different slopes. So the absorbance will go up as concentration increases, and there'll be a point. I'm going to try to use the pointer here. There'll be a point. Nope. All right, well that's not. There'll be a point between the moderate absorption and aggregation and multi-level absorption where the slopes change. And you can see on this graph where the line that says critical micelle concentration is. That is where the critical wash concentration is. So that's how we determine what the critical wash concentration was. So you can tell either in the, you could use the corrosion rate the work that we did with the corrosion current and make a plot like this. We used UV because it's a little bit easier, and you can get where that critical micelle concentration is, or the critical wash concentration is we used in the presentation.
And there's a difference between the making sure that it's effective versus where it would be like 0.
Mm-hmm.
So like she said, there's those different slopes. So if you back down that at a lower concentration, you may get close to 0. We did it so that it ensured you had sufficient coverage so that you would get a reduction in corrosion rate.
Yes.
So we weren't trying to optimize the concentration. It made sure that you were at an effective concentration.
So I think I saw one of the questions come up was how far above. What we recommend was based on salt away. So salt away was about 2.5 times the critical wash concentration. We recommend you be about 2.5 times above that critical wash concentration. So you make sure you have a nice layer, and you make sure you have that nice absorption layer and corrosion protection.
Again, and we're careful about extrapolating a lab-tested concentration to a field performance, but in an apples-to-apples comparison, right, what is clear is the relative effectiveness at these different concentrations. So it's two different issues, right? So we're trying to find kind of where that break was with the concentration. The best guess stab at the field applied concentration. You'd still want to verify and validate different concentrations effect on the field coupons.
Also, it's important to note that we found that this was very alloy specific. So if you have a specific application where you're looking at, let's say, corrosion prevention on aluminum specifically, NutriWash at the manufacturer's recommended concentration would be fine. But if you're looking, why we recommend salt away is because it was the most versatile. It prevented corrosion on all the metals that we tested, and some of the coated metal samples as well, and it was at a low concentration. So we wanted to pick something that was at a low concentration, cost-effective, and versatile. That doesn't mean that the other salt neutralizers are not effective, just perhaps not for the application that you're looking for. Yes?
On slide 34, you mentioned that neutralizer applications can increase the useful life of the truck by 6 months to a year.
Yes.
Is that an assumption, or I didn't see where the data was behind it?
Actually, the question is on the slide that's shown on the screen, how did we get a 6-month to 1-year time extension? So, and I did the analysis here. We looked at that. If you look at the equivalent uniform annual cost, depending on, and ODOT has an 8, 10, or 12-year replacement cycle. So depending on the replacement cycle, you can get a different annual savings. Okay, so the savings 6 months on an 8-year truck is going to be greater than 6 months on a 12-year. Okay, so we got to know what that part of how why the numbers change. What we did is we said if you were going to wash at 100 gallons with salt away, and you wanted to extend the life by 6 months, how often would you have to wash it? So it's trying to actually calculate, so we assumed 6 months. If you wanted 6 months life extension, and that saves you so much money, how much salt neutralizer could we apply, and how often would we have to wash the truck? So it's maybe perhaps misleading to say that we know it can increase that. It could increase, if you do the cost and you get reduction, okay, of 6 months to a year, that you could save that by applying the neutralizer. So,
well, I would imagine you would want to apply the neutralizer when you've had a lot of salt exposure. I mean, it would really...
Right, but what we were trying to see is, we had no idea, would you wash it, if you have 30 winter events, do you wash it every winter event, or roughly how many, to begin getting an idea of, and that varied from 5 to 18, depending on how long perhaps you're trying to extend it, or how the 8 to 12 year time cycle. So,
do you know within ODOT how many trucks are replaced before, if it's an 8-year replacement cycle, how many have to be replaced before 8 years because of corrosion issues?
That's actually why we have that recommendation and implementation. This data mining preventative maintenance is actually seen, because part of it's based on the 8 and 10, 12 is based on where those trucks see the highest salt exposure, where the most salt is applied is kind of how that's determined. But I don't think it's been looked at to see if that's coming in or above those estimates. And also, like I said, the wiring maintenance costs, are those related to the trucks that are on an 8-year replacement cycle, or is it independent of that? Because it could be more moderate environments, where you have higher moisture and the temperatures swing, and it's not necessarily the snow events. So that's why that really has to be looked at to begin pinpointing where the problem childs are in the truck.
Thank you.
Yeah.
Are there any, I just hit full screen here? Yeah, just hit full screen. All right. Okay, if there's any more questions, feel free to speak up online. You can type it on the side of the screen in the chat pod, or you can unmute your phone by pressing *6 and just speak up. We did have one question online about whether or not there was going to be a printout of the findings. There will be a final report that will be available on the ODOT research website. The link is provided in the chat pod. Along with the final report will also be an executive summary. This presentation has been recorded, and it will be also available on the same website, along with a PDF version of the PowerPoint that you just saw. It will probably be up in a couple of maybe 3 to 4 weeks or so, and the report will be available. So it doesn't look like anyone is typing on the webinar, and no one else in the room has any more questions.
Wash a truck. What method for washing? A pressure washer? Garden hose?
What's
The
cost, yeah, we only looked at the volume, we didn't look at the method. So we, based on another project that I'm involved with, we know that where it's 300 gallons total per wash, 350, that kind of helped to identify where maybe 50 or 100 gallons of that would have neutralizer in it. So whether you wash 200 gallons with soap and water and then you apply the neutralizer at 50 or 100, that's where we came up with that. But the actual method, because of the laboratory testing was, sort of this, well-controlled environment, we didn't look at high pressure, low pressure, those type of things. Those are field, and that's why, again, that was one of the other recommendations in implementation, is the standardized washing procedures and testing coupons with high pressure hand washers or, undercarriage, equipment, those types of things. So, yeah.
Question for you. If you were to wash these trucks with your normal facilities with just the basic soaps, and then afterwards went in, put this material into like a pump-up garden sprayer and just spray your trucks down with it, do you think that would be effective at all?
Yes, I think that would be, that's basically what we did for the washing at the salt spray facility. So I think that that would be an effective way to apply it, as long as you're following the manufacturer's recommendation for how to apply it.
Okay, with the concentrations, if you were to do it that way, do you see any problems if you were to increase the concentrations of the material in the garden sprayer? Wouldn't be a negative, would it?
No.
No.
Okay.
Other than just obviously the reduced cost benefit, or the increased cost of applying a higher concentration. And actually that was in the final report, one of the recommendations we had, and one of the outcomes of this was to try and identify, because there were some facilities that still had these different products, if they wanted to use them and be effective, to get an idea of what that concentration would be to be effective. So it's not like you just have to get rid of the neutralizer. You just need to get to an effective concentration.
Any thoughts on spraying this under the hood of a truck, onto the engine itself, all the components underneath there?
But I think that was one of the reasons why we tested different materials, was to begin getting an idea if, copper did see the neutralizer solution, what would happen. So again, based on looking at those different materials, you're going to run into that same. We saw that in many cases the exposure increased the corrosion rate. So the effective concentration or the right neutralizer, again, is the same message there.
Yeah, with the material that you recommended at the end, I think, correct me if I'm wrong, but that was the only material that was effective on all of the different metals.
No, that's correct, yes. Salt-away was the only salt neutralizer that we tested that at its manufacturer's recommended concentration was effective on all of the metals. The other neutralizers had to be tweaked a little bit in the wash procedure to be effective.
So spraying that underneath the hood of a truck with the copper connection, spraying it onto the brakes that has some brass in it, that material would probably be safe for all of those applications.
Correct.
Correct.
Thank you.
After applying the neutralizers, were they then rinsed off before?
Yes. So the question was, after applying the neutralizers, were they rinsed off? So yes, and Alvaro, they were all done that way, correct? Yeah. So the typical way is you apply them and then you rinse off with a water wash. So you have to leave them on for a certain amount of time. It does the cleaning, and then you rinse it off, and the neutralizer or the acid will bind with the salt residue and remove it.
And with Salt-away, they recommended don't rinse it off.
And again, I think that's also part of that. If in the real field application, Mother Nature, you get rain event, do you have to keep all the trucks underneath the garage, they're going to be, so part of that would be to still, we think you go to the field coupons and see how they perform, because you're not going to have any choice. You're going to have to send the truck back out. So, yeah. And it's going to be, right.
Yeah.
The corrosion inhibitors have time to work.
Right.
Yeah.
Right. Exactly.
But the surfactant, again, I don't know, the kinetics binds relatively quickly, I'm sure.
Yes.
You know
Yeah,
what
the
I mean?
surfactant binds pretty quickly.
You test how fast it comes off or not, too.
Mhm.
If the state is so worried about the corrosion and whatnot on their trucks, why don't they use stainless steel beds and buy a better quality truck that has a frame coating already built onto it? I think the money savings there would extend out your rotation time on your vehicles, and you keep your costs at bay as far as corrosion is concerned, because most stainless steels don't rust.
Again, I can't speak directly to that, but I know that that's already part of the normal replacement, was to replace the beds, and part of the normal, equipment replacement cycle. So again, my, at least awareness in several of the districts, that's already taking place. You still have the legacy of the previous vehicles that are still there.
Question for you, if we could go back to washing the vehicle with normal operations, taking a tank sprayer, spraying the material on it. If you were to be using salt away, would you need to run that equipment through your wash facility again, or could you just spray it on and leave that truck as it is until your next snow and ice event?
Oliver, do you remember what the...
Well, the recommended is to wash it, leave it to...
The normal is to wash it and leave it on. Right?
Well, leave it on, but the action of the salt neutralizer is to leave it for 2 to 3 minutes and then wash it again with water, and that will keep the surface covered with the agent, that in this case is the surfactant.
Mm-hmm.
So,
was salt away different?
Right, that's what he said. So the question is that, yes, you could clean the surface, soap and water, then spray it and leave it on to the next winter event.
Okay.
In regards to the question about where the light curable coating came from, that came from a startup company in Berea that we did all of our testing at, and they made and applied the coating for us on the metal samples. So that comes from a company in Berea.
The UV.
Yeah, it's a UV cured coating that they applied, metal specific.
Just an FYI for the gentleman that was asking about stainless steel beds. This is the city of Akron here. We are actually taking stainless steel beds off of trucks that are 8 to 10 years old that we're replacing chassis and putting those old stainless steel beds onto the new chassis. So we've seen a tremendous savings by doing that.
I said, I think that's standard practice now. So. Oh.
Yeah, it's not up yet. Read it out loud. I don't know.
So it's a comment. You want to read the comment? I'm trying to understand it, right? It says that conquest, a rust neutralizer, followed up by sealing with paint, followed up with the application of fluid film. If you could explain what the fluid film is, that may, but has greatly reduced our rust problems on our case loader and plow trucks and is a cheaper cost. Yeah, he's still typing, yeah.
For us, fluid film has proved to be very helpful, especially in pre-treatment of trucks.
Excellent. Where are you located?
Lake County.
Okay. And this kind of gets at what Dr. Monty was talking about relative to these organics that can help coat, protect the surface, and so, and act as an inhibitor.
Yes.
Okay, well, I think we'll go ahead and conclude the webinar at this time. If you have additional questions that you would like to have the researchers answer or just some comments you want to share, you can feel free to email those to research@dot.state.oh.us. I will type that down into the chat pod area so the online folks can see it. We will make sure that those comments are shared with the research team and that they get back with you. As I mentioned earlier, there will be a final report available for this study online. The web link is available in the chat pod. Feel free to scroll around in there to find it. You'll be able to print a copy of that. It should be up there in about another month or so. In the meantime, if you do have any questions, feel free to email us. We'd like to thank you for your participation, and you are all free to go.